Here's example number 4 of quadratic functions, again otherwise known as parabolas. And so there you have the question, and let's pull up the relevant notes, all right? Which again, these are uploaded to you. If you could print them off and have them in front of you while you're watching, that would be extremely helpful, I think. I hope you would look at this and say, all right, A is equal to 3 and B equals -12. And the question could be, what's C? Now C is that constant being added on the end. And I'm hearing you all yell, I hope so, that you're like, Mr. Sunset, the number that's being added on the end is +0. There's a phantom +0 out there, isn't there? That ghosty +0 sitting out there. So C is 0. Now let's keep that in mind. All right, so we're ready to go. Cookbook. Here we are. The axis of symmetry is x equals negative b, which is -12. The formula has negative, and then the number itself is negative. By the way, thinking one step ahead then, won't that equal +12? All right, and then over 2 times a, which happens to be 3 in this example. So 2 times 3 is 6, and then 12 divided by 6 is indeed 2. All right, so we're nice to you. We're making these come out nice round numbers. X equals 2. So I would think, yeah, let's scale the x-axis by 1s. And we'll go over here to 2 on the x-axis. 1, 2, and vertical line. That's what an axis of symmetry is for us. You know, there are parabolas that go sideways. Those aren't functions, so we're not going to worry about that. All right, these are going to all be the same kind of parabola that opens up or down. All right. X equals 2, that's the value of x in our vertex. So we'll put 2 in for x up here. So the function when x is 2, otherwise known as f of 2, would be 3 times 2 squared minus 12 times 2. This is just arithmetic, order of operations. 2 squared is 4, and 4 times 3 is 12. And then 12 times 2 is 24. So 12 minus 24 looks like that would be -12. So the y-axis is -12, or the y value. So we have the ordered pair 2, -12. We want to scale the y-axis in a way that would accommodate the number 12 somehow. That's up to you. I'm going to scale it, the y-axis, by, you can do whatever you want. I'm going to do it by 4s. All right? So, just keep in mind, every one of these is 4. So if we want to get to negative, so wouldn't that ordered pair be 2 on the x, and then, let's see, -4, -8, -12. That'd be 3 boxes, wouldn't it? If every box is 4, 4, 8, 12. All right? So there's your vertex, based on the scale that I chose. I don't care, go by 1s if you want to count 12 boxes. I don't know, that, as long as you identify your scale and use it as you graph, it's up to you. All right? What direction does this open? The value of A is what we look at there, and since it's +3, this thing's going to open upward. All right? Let's just write the word up, circle it, and move on. The y-intercept, that's always going to be the point where it crosses the y-axis, and every point on the y-axis has an x value of 0. So if we plug 0 in for x in that function, and I don't have a lot of space to do the work here because you ought to be able to do this in your head. If you put 0 in for x here, and 0 in for x here, and those are both going to be 0, and then plus the phantom 0, I think it'd be 0, wouldn't it? So 0, 0. We haven't talked about this, I don't think, maybe we have, but that ordered pair called 0, 0 is what people will refer to as the origin. All right, so there you go with that. Now, we learned earlier that not all parabolas have x-intercepts. I again would appeal to you to use visualization to see if this will have x-intercepts. Here's your x-axis. Here's your vertex. It opens up. If this thing starts down here, this parabola, and opens up, isn't it going to hit the x-axis somewhere over here and somewhere over here? I hope you can see that. You would hopefully go, yes, this one's going to have x-intercepts. In fact, we've already plotted the one over here to the left. and that'll come back into play. But let's pretend we didn't notice that. So how do you find x-intercepts? You put 0 in for y. And there's going to be two of them, one over here on the left, one over here on the right. Visualization, critical thinking. Y, you need to remember, is another name for f of x. So the equation would be 0 equals 3x squared minus 12x. And that is indeed a quadratic equation. So we would factor it, hopefully. It's already in standard form. I would point out we could factor out 3x from both of those terms, which leaves x minus 4 in the parentheses. This is assignment 11, quadratic equations. And then we employ the zero product principle. And again, apologies, I really would love to have more board space here. But if you set 3x equal to 0, that leads to x equals 0. And that would be one of our ordered pairs. X is 0 when y is 0. I'm going to plot that point from right here. Okay, ready? Look at that. Oh, it's already on the graph from before. Wasn't that a cool magic trick? Woo! All right, and then if we set x minus 4 equal to 0, that will lead to x equals 4. I'd love to show the steps, but you can do it. And that would be the ordered pair 4, 0. Which, okay, I'm going to do another magic trick here. All right, I'm going to plot that one from clear over here. Okay, close your eyes. You're peeking, close your eyes, close your eyes. Okay, your eyes are closed? Okay. Okay, you can open them now. All right. Look at that, I just plotted 4, 0 from clear over here. All right, how does he do this? So anyway, now look, this is 2 units away from your axis of symmetry. This is 2 to the left, this is 2 to the right. Awesome. And then basically there's our graph. All right, so not a big deal there. Actually, the factoring of this one was pretty simple. Take out a common factor of 3x, that kind of thing. So I believe there's one more parabola for us to enjoy together. And so go get something to drink, something to eat, and we'll come back and we'll do an application of quadratic functions, parabolas. All right.